In this lesson, we're going to study the relationship between exponents and logarithms. Now, this is a new lesson, so I expect you to have your journals out and be following along, copying these examples down in your notes. Please pause the video as needed in order to write the notes down. Remember that you can always rewind and replay it if you need to. Now, exponents and logarithms, we've already gone pretty in depth with exponents, but logarithms is going to be brand new. So let's start. A logarithm of a number is just the exponent to which the base must be raised to produce that number. So in a logarithm, the base is indicated by the subscript b. That is the base of a logarithm. The base of a logarithm actually correlates to the base of an exponential equation. What you're trying to do when you find a logarithm is figure out what your exponent should be for that base to end up with the value of x. This is your conversion formula. So we've seen conversion formulas before when we converted from exponents to rational exponents to radicals and radicals to rational exponents. So this is something similar. We're converting from logs to exponents and from exponents to the log. Now the formula may seem a little bit confusing, but let me put it in perspective of something that we've already done before. The relationship here is actually very similar to the relationship that you studied when you first learned about square roots. For example, if I asked you to find the square root of 9, we know that the square root of 9 is 3. And the reason why we know that is because 3 to the second power is 9. Just like you have a connection between squares and square roots, you also have a connection between logarithms and exponents. If I asked you to find log base 2 of 8, the question you want to ask yourself here is 2 to what power gives you 8? Well, 2 to the third power gives you 8, so that means that the log base 2 of 8 is equal to 3. It's that simple. So let's do a couple of examples to practice. Number 1. Log base 5 of 125. The question you want to ask yourself here is 5 to what power gives you 125? 3. 5 to the third power is 125, so the answer is 3. Another example, log base 3 of 243. The question you want to ask yourself here is 3 to what power gives you 243? 5. 3 to the fifth power is 243, so that means the answer is 5. Another one, log base 6 of 6. The question you want to ask yourself here is what's the exponent? 6 to what power gives you 6? Well, that would be a 1. 6 to the first power is 6, so the answer is 1. Next, log base 2 of 1/8. Here you want to ask yourself 2 to what power equals 1 over 8? Well, we know that 2 to the third power is 8. That means that 2 to the negative third power is 1 over 8. So our answer is -3. One more of these. Log base 7 of 1 over 49. Here the question you want to ask yourself is 7 to what power equals 1 over 49? Well, we know 7 to the second power is 49, so then that means 7 to the negative second power is 1 over 49. So our answer is -2. The next thing we're going to practice with exponents and logarithms is purely converting back and forth from logs to exponents and from exponents to logs. First, let's start by going from logarithmic form to exponential form. Anytime that you're converting here, what I want you to focus on and start with is always the base. Here we have log base p of k equals c. Start with the p. What you want to know here is p to the c power equals k. The base stays the same. Everything else switches. All right, number 7, you always start with the base. Well, this one doesn't have a base written. If the base is not written, it's automatically a 10. This is called the common log. Base 10 is the most common logarithm that you can have. It's used a lot of times with scientific notation when you've seen that in chemistry before, like 6.23 times 10 to the 29th power, stuff like that. Base 10 is the most common base that you have. It's so common that when you use base 10 with logarithms, you don't even have to write the 10. Okay, so here if we're going to convert, we're going to start with that base of 10. This would be 10 to the c power equals n. Now, number 8, this is still a logarithm. It's written differently, though. Ln is called the natural log. It goes with the natural base e. So in this case, if the base isn't written, Ln is natural log. The base here is e. So the way we would write this one, start with your base, e to the 0th power equals 1. The base stays the same. It's everything else that switches. Now let's try going in the opposite direction. Each one of these problems is given in exponential form. We have to convert it to a logarithm. So again, identify the base first. Number 9, my base is g. So when I convert this to a log, I'm going to have log base g. Then everything else switches. The b and the c switch sides. So it's going to be log base g of b equals c. The base stays the same. Everything else switches. On number 10, identify the base. Here we have a base of 10. So whenever I write this, I would have log base 10 of k equals p. The 10 stays in the same spot, that's your base, but the p and the k switch sides. Now remember, base 10, you don't actually have to write that 10 there, so I'm going to erase it. Number 11, last, we identify the base first. Here we have a base of e. E to the 3rd power equals 20. If we convert this to a logarithm, this would be log base e of 20 equals 3. Now base e is special. Instead of writing log base e, that's your natural log. So I'm going to mark that out and just put Ln, which is the natural log of 20, equals 3. The last thing we're going to do with exponents and logs is simplify expressions. Which we will do in the next class.